Hi students, in our previous module we discussed about the sine inverse of function, and in this module we are going to discuss about the principal branch values of the cos inverse, sine inverse, cosecant inverse, tan inverse, cot inverse, etc. So for that we can take a table which can help us to find those values easily, because in sine inverse function what we have done is we had just restricted the domain to minus pi by 2 to pi by 2. Like that for cos inverse, tan inverse, cosecant inverse, cot inverse, we do the same type of process. And now we will write the table on the board. Look at the table given here. Here the domain of sine inverse function is minus 1 comma 1, whereas the range is minus pi by 2 to plus pi by 2. Here cos inverse it is minus 1 comma 1. Here the range is 0 comma pi. You have to note down this sine inverse, tan inverse and cosecant inverse. So we can take these values in between minus pi by 2 and plus pi by 2. Whereas cos inverse, secant inverse and cot inverse, they are between 0 and pi. This you have to remember always. Now using this technique, how we can find the principal value of the given function? Suppose question is sine inverse of root 3 by 2 is given. You have to find the principal value of the sine inverse of root 3 by 2. It is very simple. Take this as some x. So we take sine inverse to that side. You will get sine x is equal to root 3 by 2. When sine will be getting root 3 by 2, what is root 3 by 2 first? When we take the sine function, let us take 0, 30, 45, 60 and 90 degrees. You can get the values. It is 0, 1 by 2, 1 by root 2, root 3 by 2 and it is 1. So for sine 60 degrees we get root 3 by 2. So instead of writing this root 3 by 2, we can write this as sine of 60 degrees, that is pi by 3. So both the sides we have sine, we will remove sine, so x is equal to pi by 3. This is the answer. This is called as the principal value of sine inverse of root 3 by 2. Suppose the same question is given in this way, that is sine inverse of minus root 3 by 2. The same process must be followed. Take this is equal to x. Take this sine inverse there to the other side. So we will get minus root 3 by 2 is equal to sine x. So we can write this as minus, this is root 3 by 2. This root 3 by 2 is nothing but sine of pi by 3. So this minus can be taken inside, as I told you in the previous module, that sine of minus theta is equal to minus sine theta. So we can write this as sine of minus pi by 3. So we can cancel sine on both sides. We get x equal to minus pi by 3. In this way, you will find the principal values for the sine inverse, tan inverse and cosecant inverse. Suppose the same question is given for cos inverse. So what? For example, cos inverse of 1 by 2. Let us learn all the cos values. Cos values are, cos 0 is 1, cos 30 is root 3 by 2 and cos 45 it is 1 by root 2 and cos 60 it is 1 by 2 and cos 90 is 0. Now for what value of cos we will get 1 by 2. For that first you take this as x, so that cos x is equal to 1 by 2 implies cos x is equal to, we get 1 by 2 when it is 60 degrees. So we can write this as cos of 60 degree is pi by 3. So we can cancel cos on both sides. We get x equal to pi by 3. Suppose we are given cos inverse of minus 1 by 2. Here we have to take this is equal to x. So we will get cos x is equal to minus 1 by 2. Here remember the value is between 0 and pi, that is a range. So if it is negative angle, first let us write cos x is equal to minus this 1 by 2 we get for cos of pi by 3. If the negative angles are given in cos inverse or secant inverse or cot inverse, better you write that angle as pi minus the same angle. So we can write this as cos x equal to cos of pi minus pi by 3. So this is nothing but cos of 2 pi by 3 when we take LCM of this. So our answer is here x equal to 2 pi by 3. In this way, for cos inverse, secant inverse and cot inverse, we can take the angle, if it is minus, take it as pi minus the same angle. You can solve all the problems in such ways. So in our next module, we will discuss how we have to use the formula of tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy, and so on. Thank you.